Okay, this is Perms and Comms lesson 6. This is essentially a work period, so there's not much to do, but I'm going to do a little bit of an introduction at the beginning. What we want to talk about today is we're trying to do problems when we have Perms, fundamental counting principle, and combination problems all mixed together. Because it's the mixing of the kit together and then figuring out which one it is. That's the hard part with Perms and Comms. If I do permutations one day, you guys, all the homework is on permutations, it makes it a little bit easier. Permutations, this is the same thing we had at the end of lesson 5. Permutations, the order matters. So, putting an A, then a B, then a C, that matters. Putting a code, you've got to put the numbers in the right order, that matters. Arranging books on a shelf or arranging DVDs on a shelf, that matters. Going through and talking about I'm going to pick a president, a vice president, and a secretary treasurer, that matters because putting different people in different spots matters. Okay, license plates, it matters because it's got to be in a particular order. If your license plate is ABC123, BAC231 has the same ones, but it's a different license plate. So the order matters. Those are all permutations or fundamental counting principle. The only difference between the two is with one you're allowed to repeat digits, one you're not allowed to, or repeat elements, and one you're not allowed to repeat elements. In both those cases, if there's like elements, if you've got multiple copies of an E or multiple copies of the number 5 or multiple chocolate ice cream cones, that sort of thing, you have to divide the factorials out. That's these two. Okay, fundamental counting principle, permutations. Combinations, the order does not matter. Committees is one. You're just making a group, you're just making a stew. An example, not to push gambling, lottery. Lottery is a combination. It doesn't matter what order it comes up. Now, going along with this, what ends up happening is people start to say, well, what's the deal with these formulas? Okay, where did they come from? Okay, so fundamental counting principle we're okay with. That's basic idea. We're all right with fundamental counting principle. Permutation formula is n factorial over n minus r factorial. And people say, okay, I've got that. It's on the formula sheet. My teacher told me. Where does that formula come from? Well, what it basically boils down to, you can see it in action. It's automatically happening for you when you do fundamental counting principle. Let's pretend I'm taking the objects 1, 2, 3, 4, and 5. Very simple. And I'm making a 3-digit number. Okay? So fundamental counting principle tells me that what I'm doing is I'm going, there's a first blank, a second blank, and a third blank. And what I end up with is I've got 5 choices for that first one. Now, I'm no repeats. I'm not allowed to repeat. So if I'm not allowed to repeat these things, which is what permutations is then I've got, well, 4 choices for that blank and 3 choices for that blank. But what ends up happening is you say, well, this is almost 5 factorial. I just need a couple extra numbers. I need the 2 and the 1. Okay? So you think, well, how am I going to get that? It's almost 5 factorial. So if I start with 5 factorial, I'm 5 factorial divided by this 2 times 1. I'm dividing by the 2 factorial. Now, where does this come in with the formula? Well, that's 5 factorial. And to get 2, I could have done 5 minus 3 factorial. And you wonder if that's the same thing. That always happens, but it always does. If you're rearranging them, it doesn't matter how many objects. If I say example, okay, I've got 12 objects and I'm arranging, and I'm just very general, this is not arranging a group of 7. Okay, well, you've got 7 blanks. Okay, you got 7 blanks. There's no repetitions in this particular case. So there's 12 choices there, then 11, then 10, then 9, then 8, then 7, and then 6. Okay? And you say, well, this is almost 12 factorial. All I need is that final 5, 4, 3, 2, 1. So if I think, well, that's all I need is this pencil 5, 4, 3, 2, 1, which doesn't show up very well. But if I've got that, then I could say, well, this is 12 factorial over 5 factorial, because that's what that 5, 4, 3, 2, 1 is. And then people say, well, that could be 12 factorial over 12 minus 7 factorial. And they say, well, what's going on? Well, what I've got is n, the objects, that's that number and that number, that's always going to be the same. And the size of the group is r, how many I'm arranging, that's going to be the same. So I've got n minus r down here, and that's where that formula comes from. Okay. Then people say, okay, now I got that one. I'm done with that. I'm good with that. What about the combinations one? Where does that formula come from? Okay. Well, what it is basically is it's a permutation, but you don't want to consider the orders. So if I just make a group, okay, and I say, okay, I've got 1, 2, 3, 4, and 5 again, and I'm going to place them in a group where order doesn't matter. Okay, I know this is a combination, so I know I'm going to do n choose r, which is, hopefully this is going to fit on the screen, n factorial over n minus r factorial, r factorial. Okay, so I know this is going to be 5 choose 3, and I'm all set and ready to go. But what if I don't have that formula? So what do? Well, the only formula I truly understand is permutations. So I'm going to say, well, I've got 5 pick 3, which is 5 factorial over 5 minus 3 factorial. Okay, and that's going to give me an answer. The problem is this counts all the different orders. Okay, this has the, if the three numbers I chose are 1, 3, and 5, it counts 1, 3, 5, and then it counts 1, 5, 3, and then it counts 5, 3, 1, and so on and so forth. I don't want those extra orders. So what I say is, well, how do I get rid of those orders? If I know what the 3 digits are, how many orders are there? If I know what the 3 digits are, and I'm repeating that, how many orders are there? Well, if I know the 3 digits, there are 3 choices for that one, 2 choices for that one, and 1 choice for that one. This is the number of orders of the 3 objects in this case. Okay, the number of orders, that's how many orders there are. So I've taken and I've got all those orders. If I don't want those orders, I'm going to divide them out. And so when I divide out all the possible orders, I'm taking a look at, okay, so here's all the different orders I have. Well, this ends up being 3 factorial. Okay, and this will always end up being, if I've taken a group R big, I'm going to divide out the orders, the R factorial of all the orders. So if it's 7 objects, there's 7 factorial orders of those objects. If it's 54 objects, there are 54 factorial orders of those objects. So I've got this 3 factorial. This permutation is close, it's just been multiplied by the number of orders. Okay, I don't want that. I want to get rid of those extra orders. So to do that, I'm going to divide out the 3 factorial. And then that gets rid of all those possible orders, and I'm not considering them anymore. I'm just counting them. You know what? I got all 3 of these numbers, and I'm not considering those orders. What ends up happening is you start to notice n is the 5, r is the 3. And it doesn't matter how many times you do that, that's what it boils down to. There are much more formal proofs for these, but these are the quickest way to show here's why these formulas work. So that's where the formulas come from. The NPR is n factorial over n minus r factorial. Okay, it's on the formula sheet. You don't need to remember it. In fact, you don't even really need to know where it comes from to do well in this course. But I'm hoping you understand where this comes from. NCR is n factorial over n minus r factorial. Okay, so the permutations formula, but you're dividing out all the extra orders of the r objects. And that's what happens. So you could really treat them as one and the same thing. I've talked to teachers that only teach the combination formula and then they multiply by the orders. I've talked to teachers that only teach permutations and they divide. Most people teach both formulas as separate things. It really doesn't matter. So otherwise, though, what you're going to do today is you're going to be working on a whole series of worksheets with mixed questions from old diploma exams to try to figure out which one is which. So I hope that helps. Have a wonderful day. Bye-bye.